Okay, friends, today's topic would be pertaining to the basics of ray optics. So this is an important section in your syllabus. So, what we will try to do is we will try to build up some basics around ray optics. Okay, so let's understand what a beam would contain. Like a beam would contain many rays of light, and the way the ray moves, the ray travels in the medium, undergoing certain phenomena like reflections and refractions, basically all that study will come under a category called as ray optics. This is something which you need to know. Okay, so please make a note of this slide so that we move ahead, and once you are done with it, we carry on with this stuff. Okay, hopefully done. Can you just share your feedback with me so that I also come to know whether we should move forward or not. Okay, all right, no issues. So let's move ahead. Let's understand, you know, this thing in greater detail. Now, what is each ray going to do? It's going to travel in a straight line. Always remember that it travels in a straight line in a given medium, and we call it as rectilinear propagation of light. Again, make a note of it. These slides are self-explanatory. And once you are done with it, just give me the feedback so that I move ahead. Okay. And slowly, I build up the concept for you people. So hopefully you have noted this down. Okay, each ray of light will travel in a straight line. We also call it as rectilinear propagation of light. So one needs to remember and recall this thing. Okay, hopefully done. These will serve as keynotes for you people. Not necessarily they are always in details. Okay, they can be at time very short like this. Okay, let's move ahead then. Yeah. Now, how we bend light? Okay, so obviously we bend light ray with the help of a phenomena called as reflection of light. We all know that. And how we bring about the reflection? Obviously, we want to use mirror for reflecting a light. So this is how we bend a light. This is one way of bending a light, basically. There are other ways also. So we will talk about the other ways subsequently. But initially, just to begin with, okay, how we bend the light with the help of a mirror, and which where we use the process or phenomena like reflection of light. Please make a note of this. Okay, hopefully done, I believe. Yeah. So let's move ahead then. Then there's another way of bending the light, and we call it as refraction. Now, what exactly is refraction, friends? You bring about the change in the direction of light when it travels, say, obliquely from one medium to another. And the material medium can be air, glass, and water. The medium which I'm speaking about over here is an optically transparent medium, optical medium, you can call it. Okay, this is how we define refraction also. This is another way of changing the path of light, you can say. Please make a note of this. Now, here you can see the word obliquely is important. I'll bring about the importance of this word obliquely, okay, in the subsequent slide. Once you are done with this, please let me know. Okay, so mostly you people say done, no issues then. Let's move ahead. Okay. Yeah, now how do you come across refraction or how you perceive refraction in day-to-day life examples? Like say for example, You can see a pencil is being immersed in a water in a beaker or a container, you can see. And now, because of the change in the path of light, you can see the pencil appears to be broken over here. That's the beautiful example of refraction which we can trace in our day-to-day life. Okay, there are other examples as well. Please make a note of this. Okay, hopefully you have noted this down. So let's move ahead then. Okay, another example you can see. You talk about swimming pool, right? You observe it from the top. It appears actually shallow, or the floor of the swimming pool appears to be raised when we are viewing it from the top. Now, why this happens? Obviously, because of this phenomena called as refraction, friends. So please make a note of this again. So hopefully you have noted this down. So let's move ahead then. Next example for refraction in day-to-day life, you can see the arrow will get reversed basically. You perform this experiment at home, you'll realize. Now, this is also happening owing to refraction of light. So these are few day-to-day life examples which we have, shown in form of photographs over here, just for sake of understanding refraction, how practically we can perceive refraction. At times, it's not only about understanding theory. You have to perceive it in terms of practicals also. Hopefully, you have noted this down, friends. So let's move ahead. Yeah, here comes the diagram. For how
Sir,
refraction
can
would.
you show the last slide?
Yeah, yeah, no problem. Definitely. Yes. Once you are done with it, let me know so that we move ahead.
Done, sir.
Okay, no problem. Yeah, friends, here you can see, a ray of light is changing its path when it is traveling from air to glass. Now, when I'm saying air, air is comparatively rarer medium, optical medium, as compared to glass. Glass is more optically dense. So, whenever you can see a ray of light which is moving from rarer medium to denser medium, it will bend towards the normal. So this is the refracted ray, this is the incident ray, and say this is the normal. It is bending towards the normal. Okay, so always remember whenever a ray of light will move from a rarer medium to the denser medium, the ray of light will bend towards the normal. Okay, so here stands now the angle which incident ray makes with the normal, we will call it as angle of incidence. The angle which the refracted ray makes with the normal, we will call it as angle of refraction. Now, one more thing which you should note over here is when the ray moves from air to glass, that is rarer to denser medium, it is bending towards the normal. Therefore, angle of refraction in this case would be obviously less than angle of incidence. Okay, this is an important inference which you should draw. So many things, are made clear, and we can establish laws of refraction over here. We all know basically what laws of refraction are. Okay, so the incident ray and the refracted ray, they will lie on the opposite side of the normal. This is the first law. And second, they all lie in the same plane. And the third and foremost important law is regarding the Snell's law, which gives you the definition of refractive index. Okay, so that means the ratio of sine of I to sine of R remains constant. And these are the laws of refraction which are established with this experiment of a ray traveling through glass slab. Please make a note of it. Once you're done with it, please let me know so that we move ahead and start slowly getting into the greater details of it. please share your feedbacks, okay, so that I come to know when to move forward. Okay, so most of you say done. So let's move ahead then. Okay. Yeah, now when we talk about optical density, again, we need to bifurcate the optical medium, into denser and rarer. So glass is a medium which we will call it as a denser medium. Why? Because it will slow down the speed of light more as compared to air. So that's why we can say if the optical density is more slowing down of light will take place. The speed of the light would decrease to optically denser medium. All right. So a material that is denser need not be more optical denser always. Okay. This is again an inference for us people. So please make a note of this before I show you the next slides on the same concepts. Okay, hopefully done. Let's move ahead. Yeah, here is a case. Why did I say, the word obliquely is very important? Because when we define refraction, we define it as change in the direction of light when it is traveling obliquely from one medium to another. So let's understand if it is not traveling obliquely, then what would happen? You can see case 3, where it is not traveling obliquely. So it's not getting refracted also. Angle of incidence is also 0 and angle of refraction is also 0, you can see. So if a ray of light travels or changes the medium vertically like this, obviously refraction is not going to take place. Therefore, in the definition, this word is predominantly introduced, okay, obliquely. Now let's talk about case 1. In case 1, the ray is traveling from rarer to denser medium, therefore the ray is bending towards the normal, you can see. And therefore I is greater than R for case 1. Had it been other way around, if the ray was traveling from a denser medium to rarer medium, you see the ray of light bends away from the normal, thereby rendering angle of refraction greater than angle of incidence. If you all recall and remember this. All right, friends. So please make a note of it. Okay, very important slide. And once you are done with it, please let me know if you're done with it. Okay, hopefully all of you say done. So good. Let's move ahead then. Yeah, this is the law of refraction, Snell's law of refraction, which I was talking about. And what it says, say for example, let's look at the diagram. Okay, so interface, the first word which we come across is the interface. Now, what is the interface? Basically, it's a boundary marking or demarcating basically the boundary between the two different mediums. So that is interface. So at the point of interface, the refraction is going to take place. So the diagram itself tells you the ray is moving from rarer to denser medium. Now N1, which is also denoted by mu at times, but then here we are denoting it by N. So N1 stands for the refractive index of the first medium. N2 is the refractive index of the second medium. V1 stands for the speed of light in medium 1 and V2 stands for speed of light in medium 2. Now in both the perspectives, we can define Snell's law basically. And what it says is the ratio of sine of I means angle of incidence, to sine of R means angle of refraction, will be constant for two pair of media. Okay, and you can always equate them to, you can see sin I by sin R will be N2 by N1, where I just now told you N2 is the refractive index of medium 2, n1 is the refractive index of medium 1. But the same thing can be also established in terms of velocity. If you see v1 by v2, where v1 stands for velocity of the light in medium 1 divided by v2. V2 stands for velocity of the light in medium 2. So this is a very important law, and time and again we are going to use this law to solve problems or to make some interpretations so far as ray optics is concerned. Please make a note of it and let me know once you're done with it. Yeah, so most of you see done. So let's move ahead then. Okay, good. Now let's understand, how the entire refraction through the slab will take place. So this is about a parallel slab. Here we were just talking about, a single slab you can see. But now we have a parallel slab over here. So let's understand how things would be. Okay, so let's understand this. Say T stands for the thickness of the slab, basically. So the ray of light is moving from air to glass. So obviously, instead of going like this, as shown by the dotted line, it bends towards the normal, thereby making R as angle of refraction. All right. And then again, it is incident at this point. Again, the change in the medium is going to take place. But now the ray of light is moving from denser medium to the rarer medium, and therefore it will bend away from the normal. So you can check out this arrow. At this point, it bends away from the normal. So, parallel, if you try to work out geometry, this is also I, if this is I, basically. Now, what is the lateral shift, if I want to know? See, ideally, if the glass slab was not there, then the ray would have traveled directly like this. But because the glass slab is there, the ray bends and it deviates. Now it deviates by what amount? So it deviates by amount d. So this d will be called as lateral shift, friends. Okay. So we need to know what the formula for lateral shift would be. So in this case, lateral shift d will be given by t multiplied by sine I minus r upon cos r. So you need to know this formula. Okay. T stands for the thickness of the slab over here. You know very well what I and R stands for. I stands for angle of incidence. R stands for angle of refraction, friends. So please make a note of this before I actually move ahead towards the next slide, and let me know once you're done with it. So slowly we are getting into greater details for refraction, friends. Okay, hopefully you have noted this down. So slowly we will proceed further. All right. Okay. So let's move ahead then. Okay. So let's understand how the apparent shift would look like. Say, for example, if you are looking at a coin from the top, the object, if it is here, its image is formed here. That means it appears to be raised if you are observing it from a rarer medium. That means if you are putting a coin in a swimming pool and observing it, it would appear to be raised. So D will be the original depth of that object. But what is D dash? D dash will be the apparent shift, you can say. That's when you are observing the coin from air into the swimming pool, basically, which is in the swimming pool. Other way around, if you are observing it from swimming pool and the coin is in air, then you can see it will be appearing raised in this manner. This would be the image. So the original height or depth would have been D. but then it appears to be d dash. So this d dash in both the cases would be called as apparent shift, friends. So we need to understand the formulation for apparent shift also. So d dash stands for image depth. So that will be always given by original depth divided by the relative refractive index. Now, what is the relative refractive index, friends? It's the ratio of, this is refractive index given by a Greek notation called as mu. You either can represent it by n. Earlier we have represented it by n. Now few books they also represent it by mu. That is also correct. So mu stands for refractive index and relative refractive index. Now when I'm saying relative refractive index is the refractive index of object divided by refractive index of observer. All right. So in the medium where the observer is basically. Okay. And refractive index of object means the refractive index of the medium where the object is. All right. Now once you know this, then this is the relation between the real depth and image depth. So apparent depth then can be considered as, you want apparent depth. What is apparent depth then? D minus D dash would be the apparent depth. Okay, so you can see D minus D dash. So apparent depth, if you want, so D minus image depth, that is D upon mu, relative. So very, very important slide, friends, where you actually work out problems on refraction, where the questions are asked on the raised height of the coin placed in a container containing water and so on. Just give you an example. There can be a number of examples on this. So please make a note of this and then we move ahead further. Let me know once you are done with it. So most of you say yes. Okay, great. So let's move ahead then. Yeah, it may not be every time the medium, there would be only two mediums and a single interface. At times, there can be layers of interface. So, if observer is standing here and there can be n number of layers of the medium. So medium 1 will have refractive index n1, medium 2 will have n2, medium 3 will have n3. And NO stands for the refractive index of the medium where the observer is present. And let's say T1, T2, and T3 are the thicknesses of the corresponding mediums basically. And T1 is the distance where the object lies in medium 1, and observer is observing this object from this particular point, covering all these layers, and is trying to look up to this object. Then in that case, what would be the apparent shift? So the name of the topic itself suggests apparent shift for the composite slab, friends. Okay, so what would be the apparent shift in that case? So here you can see the total apparent depth. You can find it out from distance of final image from the final surface. So you talk about T1, you talk about the relative velocity n1. You talk about T2, you talk about relative velocity, refractive index for the second medium, T3, and so on. So there can be n number of mediums, but here there are only three. Therefore, the formula incorporates only three terms. Had there been four, there would have been fourth term. So, this is how you can analyze layers to get the apparent depth, basically. All right. So this is something which you need to know, friends. Please make a note of this. At times, the slides are kept self-explanatory so that it becomes really easy for you to understand and analyze. Once you're done with it, please let me know so that we can proceed further. Okay, hopefully done. Let's move ahead. Oh, okay, fine. So today's